Okay, so let's take this a step further. All right, so on the moon, the bullet goes up, right? It takes 320 seconds for it to fall back down to the ground. But on the Earth, it only takes 52 seconds. So now let me ask you, and you've already done this work, so don't tell everybody mine. But what is the maximum height the bullet reaches on the moon versus the maximum height it reaches on the Earth? Do it with calculus. Maximum height. Both planets. Not planet. Both places. There you go. Thank you. I appreciate it. Yeah. But I said with calculus, so make sure you're not just calculating a maximum. Mac does. We didn't do this really. Well, we talked about it briefly. I posted a video for him, but he didn't watch it. Yeah, because meters, I think. Feet. What is that? 5.2. How high does the bullet go on the Earth, and how high does it go on the moon? Yeah. Good. This is what I think makes these so hard, is understanding what it is they're asking you to do. It's not that you didn't know how to do any of it, it's just making it. What did y'all get for that one? Is that what y'all got? 832 times 160 minus 2.6 times 160 squared. No, I got my little calculator right here. Oh, I didn't do times 2.6, I did times 2.2. Oh my goodness. I got 66 feet. That makes sense. Good. Makes sense. Yeah. I didn't get time. Yeah, I ran out of time. It's okay. It's okay. Yeah, it was quick. I know. Calculus never looks the same. No one problem looks like all the rest of them. You'll figure it until we get to all the FRQ practice, and then you'll start going, wait, there is a pattern to these. Figuring out. Do what now? It's so much fun. I said I almost ran y'all an FRQ today, but I might do on Friday. I might do an FRQ that we can do 2 or either 3 parts of. We won't be able to do the integration part, but it's position, velocity, and acceleration. We might just so you can start to see how. Because I always talk about, oh, this is how it is. And yeah, I do too, Lainey. I do too. It's logical. Exactly. It's not like English where I don't like the way that sounds. Wrong. Right. Exactly. All right, what'd y'all get? Yes. The highest it goes on the moon as compared to the highest the bullet goes on the Earth. So where did it go higher? On the moon. Does that make sense? There's no gravity. There's no resistance as it goes up, right? Or less resistance as it goes up. Yeah. 5.2. Where do you see 5.2? Oh, the derivative. Yeah. So whenever I took the derivative of this one, 2.6 times 2. The moon, which makes sense, right? Because gravity pulls against something going up. So if it goes up with less resistance going up, it should be able to go up further, right? And it took longer because it went up further, right? And again, there's less gravity. It went up quite a bit more. Does that make sense? Give me another one. What one? 14? I'll probably run all the way through 19, just so we go through one beginning to end. 14. 14. The equations for free fall near Mars. So this is very, very similar. So we got Mars being S equals 1.86 t squared. And then we have Jupiter, 11.44 t squared. Bless you, bless you, bless you, bless you, bless you again, bless you again. Bless you, bless you. No, you're good. You don't have to apologize. How long would it take how long, what am I looking for, Robert? How long will it take? So time, right? I already know I'm looking for time. How long would it take for a rock falling from rest to reach a velocity of 16.6 meters on each planet? Yes, I agree. So what equal to that? The derivative, right? Because I'm given, what? All right, because right now I'm given position, right? And it says, how long will it take for velocity to get here on each planet? When will that happen? Yes, yes. I told you knew how to do it. You just didn't know how to interpret what it was they were asking. Yeah. I'll make that happen for Friday. Freaky Friday. FRQ Friday. Okay. Well, y'all should name it. Y'all will be my first class to name the bug. Barb. I think I'm going to do 2 bugs. I'm going to do a bug that moves horizontally and then a bug that moves vertically. So, and then maybe so that I could like use it, like have numbers on it so I could actually use it whenever we do problems like that. That would be cool. Oh, okay. Huh? Calci? Or just Cal, the bug. Cal, the bug. What did you do here? Stop, Robert. You haven't done anything? Yes. When does the velocity reach 16.6? What the heck? That's exactly, or not plug it in, but set it equal. That's right. I know that's what you meant. You just said it wrong. Velocity here would be the derivative of the position function. So 1.86 times 2. (3.72t). So the question is, when is velocity 16.6? Not s, no, s is position. You set it equal. You set velocity equal to 16.6, because when does that happen? When means I need a t. Robert, I have complete and total faith in you. You can do this. How many decimal places should I always take things out? They want 3, and I tell you go 4 to be safe. But at least 3. 3 gets you your answer point. 3 decimal places, yeah. No, I don't really understand those, so no. Why? This is easy. You can't just come in on one day and look in the middle of a chapter and. I'm not taking my card down. Say again? Yeah. I'm gonna do the whole 19. I'm gonna run all the way through it. Quickly, what'd you get for Jupiter? Robert, what'd you get? Why haven't you done it? If you have to, if it's regular rounding rules. So if the next one is, so if I was going 3 places, it'd be 726. What did I actually find here? What was that? It took on Mars. It took almost 4.5 seconds to reach 16.6 meters per second, right? Whereas on Jupiter, it took less than a second to reach that velocity. That's pretty cool, right? Yeah, they are. They actually are. Yeah. Yeah. Physics, astronomy, all that comes. Who? You know what? You know how there's. That's perfect because you've got Newton and well, I never know how to say it, but the 2 different forms of derivatives are the 2 fathers of calculus. One could be named Newton and one could be named Leibniz or whatever it is, however you say it. Leibniz, I don't know, look it up. L-E-I-B. Descartes. That was Descartes. L'Hopital? That's one we learn here. All right, let's look at 19. Okay. So they're the 2 fathers of calculus. They're the ones that. That's what it should be. That's what it should be. Thank you. That was a good idea. All right, 19. I'm going to run. Several of you asked for different parts of this. I'm going to run through the whole thing, start to finish. Ready? This is just a generic particle. So here's my bug moving right along. And so if you think about what's going on here, this is a parabola, right? So my bug is literally, here's my bug. He's literally just tracing this parabola. Backwards, forwards, up, down, whatever as I go. So that's what I'm looking at. What? Say that again? Why do you know this? How do you know? You've seen a TikTok. You did it. So all. In elementary school, there was like ants in our classroom. The AC catching on fire. All right. Let's find the displacement. I quickly gave you displacement formula yesterday towards the end, I think at some point. Final minus initial, right? Final position minus initial position. So I have to think about this before I start because initial position is easy, right? That's just zero. That's when time equals zero. Yes? How am I going to do that? Where'd you get 5? That's right. That's right. Do y'all see that? Find the displacement during the first 5 seconds. That's the how far he is from where he started. Okay, so that's what displacement means. Change in position. Change in position. Which one what equals 0? Final position is when time is 5. And the reason for that is because it says during the first 5 seconds. So first 5 seconds would mean from starting point, which would be 0 seconds, to 5 seconds, right? So when t is 5, what is that position? Oh, what? Is it? No. Well. So what is the displacement here? What's the change in position? 10. I don't have any units here, do I? Yes, I do. Meters. 10 meters. Make sure you are getting in the habit now of writing your units because you will lose your answer point if you don't put the correct units. And that would suck. Each FRQ is worth 9 points, and one of those points is always the answer for each part. So you could have like 4 possible points just for your answer point. And if your unit was wrong on each one of them, then you already can't get more than like 5 out of 9. 2 and 4. 2 calculator and 4 non-calculator. No. Yeah, use your words, Robert. Let's go. What don't you know? Do you understand what displacement means? Change in position. I don't know, like everything is like. Help me. Yeah. There you go. Thanks, Avery. I just don't find All right. Part B. Find the average velocity of the first 5 seconds. Okay, but here's the thing. I think this is on your little green sheet. Average velocity whenever I only have, so you don't know that second one. X of t is the same thing as S of t. You don't know integrals yet, so you can't do the given velocity one yet. Okay, so we're going to go to the given X of t. Average velocity here is just a rock of position. You can't do the one with the integral. The one that says 1 over b minus a times the integral of, yeah. So we're going to do right now, every time it asks you for average velocity, you're doing the one that says given X of t, which is position, which is change in position divided by change in time, which is nothing more than a rock of position over that interval. So what's the average rate of change of this position over the interval? What's the interval I'm looking at again? 0 to 5, right? So S of 0 we know is 2. What's S of, we already found this in part A. I don't have to re-find it. It's 12, right? So now the average rate of change of velocity, 12 minus 2 over 5 minus 0. It's 2. Use your correct units, meters per second. Okay, I found velocity at each one and just found the average rate of change between the two. Yeah, a lot of it is. Maybe not. How about the instantaneous velocity when t equals 4? So now I'm looking, I'm not an AROC anymore. Now I'm IROC, so I need to take the derivative. So I'm going to do the derivative of s, right? That's going to give me instantaneous velocity, 2t minus 3. So what's the instantaneous velocity when t equals 4? So plug it in. 2 times 4 minus 3, which is 5. Again, meters per second. Look at the difference there. When I find an average, it said when t equals 4. All right, part D. Find the acceleration of the particle. So now I'm the derivative of velocity, right? Acceleration is going to equal, it's just 2. What does that mean? It's always 2 meters per second per second. Because what's the derivative of 2t minus 3? Okay, so it's got a constant acceleration over the whole time it's traveling, it's accelerating the same rate. Well, but okay, if a of t is 2, what's a of 4? It's still 2. What's a of 10? What's a of 7? There's no variable. Right. The derivative of a linear function is a constant. Yes. Because I take position, take the derivative to find velocity, and then take the derivative of that to find acceleration. Remember PVA, PVA. Huh? What's what? So it always goes, as I continue taking derivatives, right? If I took another derivative, it'd be meters per second squared per second. Because I'm taking, remember how I did, I'll say dv dt, derivative of velocity with respect to time. What were the units velocity was in? Meters per second, right? Because think about speed, miles per hour, meters per second. And then what are the units that t is in? Seconds. So it's meters per second, which is why it's meters per second squared. That's why we will get to the point where you will see why it's important that you know what variable that is on the bottom. We'll take it with respect to others. Make sure you go when it's time. All right, part E. At what values, all right, here we get into some more calculus, and here is where your sign analysis will really help you, right? At what values does the particle t change directions? So for changing direction, and I don't know how, if you want to switch over to your notes, make sure you put this. This is a common question, changing direction. Changing directions is where velocity, this might even be on your little green sheet. I don't remember. Here. Pass that back to Robert. Changing directions happens when velocity changes signs. Changes sign. And that can only happen at zeros, but be very careful because it may not happen at every zero. Just because it's a zero doesn't mean it changes signs. It could, remember that multiplicity, it could hit the axis and bounce, or it could go straight through. If it goes straight through, that's when I have a change of direction. But if it bounces, I don't. So let's look at it. What's the velocity equation here? I lost my place. 2t minus 3. So where does 2t minus 3 equal 0? 3 over 2 equals t. So that means at the time, okay, so now I'm going to look at what's happening with velocity to let it tell me what's happening with position. When I am less than 1.5, maybe 0, okay? Doesn't, well, actually 0 is my end here. I can't go below 0 seconds, right? I'm not going back in time. So maybe at 1, what is the sign of velocity? Negative. If I were to graph it, that's where it would be below the axis, okay? So I'm looking back at my velocity and I'm picking, maybe I said when t equals 1. So v of 1 would be -1. So then it's which is less than 0, right? Which means it's negative. That's how I get this negative sign. And then that tells me if velocity is negative, what's the position graph doing? Left or down, right? And because this is a parabola, I'm going to say down. Does that make sense? Do you see how I'm using this to look at which areas are increasing and decreasing? Okay. Velocity, okay. The velocity equation. Everything down here has to do with velocity. So I took an example of a number in this range and I plugged it into velocity and I got -1, which tells me any number in this area will give me a negative sign. Okay? And if my velocity is negative, because velocity is slope of the original function, right? That means my function is decreasing on that interval. Yep. Yep, that's what I'm fixing to do. So what's a good easy number I can plug in past 3 halves? 2. Okay, so if I plug in t equals 2, I get a positive number. Do you agree? Which means my position function is increasing. That means velocity would be below, correct? It went through. That was us testing to see what's happening there because it asked me, did it change direction? Well, it did because it was going down and now it's going up. So it did change direction here. Had I plugged it in and I'd gotten a negative number here and it did that, it wouldn't have changed direction. It paused for just a second. Maybe my bug got tired for a minute and he walked, he stopped, and then he kept walking in the same direction. But this one, he started walking at a 1.5 seconds, he stopped, and then he went back the other way. Are there more than one? Not for this one, there's not. And that didn't pass the test? None. Then it never changes direction. Yes, that is correct. That is correct. So if you think about it, so I've got a parabola, right? And it's a parabola that opens up. So it makes sense. He moves down, down, down. This would be the point. The velocity graph would look like that. But well, because what this is telling you is saying velocity is negative. This is 3 halves. Is velocity negative here? Yeah, it's below the x-axis. So here velocity is negative and here it is positive. Remember with velocity, I'm just looking above the x-axis, below the x-axis. When's it negative? Positive? Because this is describing position and not velocity. The top describes position, the bottom describes velocity. It helps me, the velocity helps me determine what the original graph is looking like. Could you also see that now I could conclude that this is a minimum value rather than a maximum value? Does that make sense? Maybe it had asked me, does he reach a minimum height or a maximum height at this point and why? Well, he'd reach a minimum height, right? Because my function is decreasing and then increasing, or because my velocity is changing from negative to positive. So what if it Oh, does it? Okay. Oh, sorry. I didn't read ahead. Yes, you would say it never changes direction. All right, so here's something else for you to add. A minimum. This is justification when they ask you why or how you need to find it. For a minimum, you can say the function changes from decreasing to increasing. But your optimal justification here would be calculus-wise, and it would be, so I'm going to star this one, it would be the sign of velocity changes from what to what? From minimum. From negative to positive. So that's how we use calculus to justify a minimum. The derivative sign changes, or the velocity, because I'm looking at position, changes from negative to positive. And then, of course, for maximum, I would just change those around. Well, they always ask you to justify. And literally, this sentence is what you have to put to justify. Like, they will look for that. We'll practice writing paragraphs of what we would need to do. Positive to. But that's what they're looking for. Did you make the connection that when the sign of velocity changes is when those maximums or minimums occur? Are y'all tracking with me? Too much? Is your brain fixing to explode? Okay, so 19F had asked you, where is the particle when S is a minimum? Negative 1/4. Yeah, it's what we've been doing. They just asked it a little bit differently, right? Where is it when the minimum occurs? Well, I know when the minimum occurs. The minimum occurs at 3/2 seconds. So how do I find where that is? If they ever ask you where, that's position, right? Where is it? So go to the position. So what's S of 3/2? And you should get negative 1/4. Now, does that make sense that my position is a negative number? What does that mean? He's moved backwards more than he's moved forwards, right? And that's okay. Does that make sense? He's 1/4 of a meter behind where he actually started. He moved forward, then he moved backwards, but at this point, right? Or he moved backwards. Can you have a negative position, is what I'm asking you essentially. I need my Yes, I can have a negative position because if I started, and depending on where I started, what if I started at 5 and I moved backwards 10? Where am I now? Negative 5. So it's just a measure of where you are. Don't get caught up in the negative there. What time's our bell ring? 55? Okay. Pick one. Okay, what did you ask at the very beginning? 20 what? All right, let's do. I think let's look at 25 because 21 is a lot like the one we just did. Other than when is the particle at rest? When does a particle rest? How do you find that? Was 0. Velocity equals 0. It's not asking me does it change directions. It just says when is it at rest. It's at rest every time velocity is 0. 21C. And then 21D says describe the motion of the particle and when does it change direction? Same thing, from 0 to 3/2, like this one, it's moving down or left. And then from 3/2 till the end, it's moving right or up, whatever way the problem is set for you. All right, let's look at 25 because that's a good one. Ready? You need all of 25. Everybody probably needs all of 25. 6 times 1 minus t over 12 squared meters. So to give me the units here, it says it takes 12 hours to drain a storage tank by opening the valve at the bottom. The depth y of fluid in the tank t hours after the valve is open is given by the formula blah. Find dy dt at which the water level is changing at time t. Okay, so this is the same thing that I've been doing. I'm just, now they've put words to it and they've given you an actual problem. Instead of just a particle or a bug, I'm actually looking at how something is draining out. Okay, and right now, if it's draining out, would you expect your rate to be positive or negative? I would expect it to be negative as well because it's draining out. Yes? All right. So it says find dy dt. Now, what are my units going to be for dy dt? Meters per what? Hour, because it's over 12 hours. That's right. And notice that it takes 12 hours, so my time is going to go from 0 to 12 on. I don't know if they're going to ask me about displacement or any of that, but just in case they do. All right, so dy dt. Now, because this is squared, I'm going to have to work with this just a little bit before I take the derivative. I can't take the derivative the way it sits yet. For one, you haven't learned chain rule yet, so you can't. So I'm going to have to expand this out just a bit. Yep. What if I make this bigger? Or you want me to change it to black? Right? I'm going to need to like FOIL this out so that I can actually take the derivative. So 6 times what? I'm not sure what you're asking me, to be honest. Oh, so no, because it's not going to work. Without that, just because we're short on time, it's just not going to work. FOIL after call. Just trust me. All right, so I'm probably going to go ahead and distribute this, even though you really don't have to, but all of those are divisible by 6. 24 plus t squared over 24. All right, here's my y. Are we all in agreement? All right, so if I do dy dt, I'm going to take the derivative of y with respect to t, which is nothing more than dx dt. It's just the derivative, regular derivative y'all been used to doing, right? What's the derivative of this? -1 plus which is right. Well, think about it as 1 over 24 times t squared. So multiply and subtract 1. Oh, y'all little cheaters, it gave you the units in parentheses. It said find the rate dy dt in meters per hour. What m? That means meters. They just meant meters there. Yeah, that was a little confusing. Yeah, that's the answer for part A. So then part B says, when is the fluid level in the tank falling the fastest, the slowest, and what are the values? So if I'm talking about falling or rising, I'm talking about a what? Maximum and minimum of what? Of velocity, y, or of the derivative, because here it's not position and velocity, right? So I'm talking here, when is the fluid level of the tank falling the fastest? So when is the rate the greatest, right? Rate means derivative. And when is the rate the lowest, right? The beginning and the end, right? That it's a linear function, the derivative is. So when t equals 0 and when t equals 12, right? But that's not all it asked me, because it said, what is that rate? Well, when t is 0, what's the rate that it's right? I'm plugging into this. That's what you have to look at. Which equation is it that I'm using? And I'm using this one. So this would mean, because that is the rate. And because it asked me, when is it falling the fastest or the slowest? And intuitively, it makes sense. Right, meters per hour. There you go. If you have a line with a positive slope, when is it the highest and when is it the lowest? Where did it come from? Because it said it takes 12 hours to drain the storage tank. I know. So then at t equals 12, what's my rate? Meters per. So when is it? Well, that's because it's done, right? It's done, so it makes sense that it's not. So this is the lowest the rate ever goes. Well, because it's draining out is the only reason it's negative. But remember, speed is absolute value of velocity. So the speed, yes, the speed is 1 meter per hour. The velocity is negative 1 meter per hour, right? Because, no, you don't have to see right now. We'll get back to it. All right, let me tell you what I want you to do. I'll leave you a sheet for tomorrow. If you want to come back by and grab it, you certainly may. Oh, man, I don't know. Did y'all do 37 last night? Okay. Let's do 34, 35, and 37. And then let me give you these multiple choice ones here. 42 through 45. And then I'm going to have you a sheet for tomorrow. I'll leave it on my desk. No, these are multiple choice. No, we'll make everything due on Friday whenever we come back together. So you'll have time to work with us. Huh? Yeah. Okay, you got to foil it out first. Oh, thanks. Okay, what's it asking you to do? Instantaneous velocity at time t. So I'm going to do the derivative. So 3t squared minus 16t plus 20. They just factored it.